So in this video, we're going to go over the symbols for some common circuit elements that we'll be seeing. This is very important because the vast majority of our class is going to be just looking at circuit diagrams and analyzing what is going on. And so you need to understand what the individual symbols are, or you really have no way of figuring out what the circuit does in general. Now the first one is called a general element. We won't actually use this very often, but basically if you have a circuit that is several things combined together and you'd like to group it as one symbol, you might use a box. Or maybe it's a circuit element that you don't really know what it does just yet, you just leave a box. Or some other combination of reasons why we might use a box for things here, but it'll happen sometimes. Now because it can stand in for many different situations, there's no particular unit for it, but that's okay. Next up is the resistor, which looks something like this, and the unit for that is ohms. Now my resistor drawn there is absolutely not perfect, and I don't expect yours drawn to be perfect either. As long as it gets the concept down of what it's supposed to be a resistor there, that's fine. Next up is the symbol for a capacitor. It's just two parallel lines like this with a gap in between them. And the units for capacitors are in farads. I do want to point out on the side here that you are definitely not going to be dealing with any capacitors whose value is 1 farad. It's going to be something in like millifarads or microfarads or something like that. Next up is an inductor, and it's going to look something like that, and our units for that are henries. All right, that's our H there for henries. Then we have the sources that are going to be powering our circuits. They're going to be voltage sources and current sources here. Now the symbol for a voltage source, I can draw it vertically or horizontally here. It's going to look something like that, a circle with a plus and minus in between it. Now, what does that even mean here? So if I write a voltage source and say it's 5 volts here, what that means is that if you were to take something that's a point on top of the voltage source or the plus side and look at the comparison point on the negative side of the voltage source, that there is guaranteed to be a 5-volt potential between these 2 points. Now I'm going to have a separate video on what voltage is, and we'll talk more about it later, but just keep in mind that, for example, if this bottom here, if that point by itself had happened to be, 3 volts, then you're guaranteed that this top point is going to be 5 volts higher, or 8 volts. So always the plus side of the voltage source is indicating the point that has a higher potential, and the negative side is the point that has a lower potential. Now, something that you may not have seen in your physics classes is a dependent voltage source, and it's going to look like a voltage source here, but instead of having a circle around it, it's going to have a diamond here. And again, it can be horizontal or vertical. The units are still going to be volts. It's still a voltage source, but the value is going to be involving a variable somewhere else in the circuit. So maybe you have, let me make up a problem here. And let's say I'm going to measure the voltage across this resistor V1. Maybe I will have this dependent source that says that the voltage on that source is equal to 3 times V1. And so if your V1 happened to get bigger, your dependent source would get bigger, and vice versa. So dependent sources are voltage sources, but instead of giving you a fixed value for them, they have a variable value and we just have to use that as part of our equations here. We will talk in a later chapter about how a dependent source might actually work in a problem. Okay, the next one is a current source, and again you can do those vertically or horizontally. And the current for that is amperes here. Now what is a current source? Whenever you have a current source, and let's say it's 5 amps, that means that on that wire there is guaranteed to be 5 amps traveling through it of current, period. So current sources force there to be a specified current in whatever path it's connected to. And then lastly, the dependent current sources, same thing as dependent voltage, but you have, the arrow now instead of the plus and minus. And that's pretty much everything we're going to see in this class, with one small exception called an op amp, but we'll deal with that when we get there.